Let's do Brahmanad. Om. Om. Santi. 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 Swastha. Dear student, welcome to chemistry class. Myself Pavitra Mohan Mahapatra, lecturer in chemistry. Now I will discuss a new chapter. This is your first chapter. The name of this first chapter is Basic Concept of Chemistry. At first I will discuss about science. What is science? The knowledge acquired by observation, tested by experiment, and arranged in an orderly manner is called science. Science कहले ओडिया रे आमे विज्ञान कहि थाओ. Observation means पर्यवेक्षण, experiment means परीक्षा. जो नॉलेज को आमे परीक्षा, पर्यवेक्षण, सिद्धांत द्वारा उपनीत होई एक्वायर करिथाओ ताको आमे साइंस करिथाओ. There are different branches of science. Like you think about physics, chemistry, botany, zoology, mathematics, computer science, like that. Now I will discuss about what is chemistry. What is the meaning of chemistry? The branch of science which deals with the study of composition, structure, and properties of matter is called chemistry. Chemistry means rasayana vigyana. Composition means gathana. Structure means saranchana. Property means dharma. Matter means padartha. जो विज्ञान द्वारा आमे पदार्थर गठन, संरचना और धर्म विषय पढ़ी थाओ ताको आमे केमिस्ट्री कहि थाओ. The branch of science which deals with the study of composition, structure and properties of matter is called chemistry. There are different branches of chemistry such as number 1 is your physical chemistry, number 2 is your organic chemistry, number 3 is your inorganic chemistry. Like that, there are also other type of chemistry, that is your analytical chemistry, green chemistry, nano chemistry, etc. Basically, in plus 2, we generally deals with the physical chemistry, organic chemistry, inorganic chemistry. Physical chemistry means भौतिक रासायनिक विज्ञान. Organic chemistry means जैव रासायनिक विज्ञान. Inorganic chemistry means अजैव रासायनिक विज्ञान. Let me explain what are the application of chemistry. Why we need chemistry. There are large number of application of chemistry in our daily life. For example, food. Next application of chemistry is in cloth, shelter, communication, transportation, health, that is your medicine, like that. Next, I will discuss about matter. What is matter? For better understanding, I will take an example. Suppose I will take pen. Pen having some mass. Pen occupies some space. We know that pen is a matter. That means matter is anything which is having some mass and occupy some space are called matter. Mass means vastutva, space means jaga jo कहते हैं. Anything which having some mass and occupy some space is called matter. You can take example pen, chair, iron, aluminium, carbon like this. जार किछि मास थिबो आ रखिया पई किछि स्पेस आवश्यक पडुथिबो ताकू हमें मैटर कहबा. Our universe is made by two things. One is matter, another is energy. Our universe दीटा जिनिस नेकी होइता है. गोटे हला matter, अन्यटे हला energy. Next I will discuss about the classification of matter. Matter को हमें केमिति classify करि परिबा. Matter classified in two different ways. One is physical classification. Second is your chemical classification. At first, I will discuss about the physical classification. फिजिकली मैटर को हमें तीन भाग में डिवाइड कर परिबा. फिजिकली मैटर कैन बी क्लासिफाइड इनटू थ्री टाइप्स. वन इज सॉलिड, सेकंड इज लिक्विड, थर्ड इज गैसियस. सॉलिड मीन्स कठिन, लिक्विड मीन्स तरल, गैसियस मीन्स गैस. At first I will discuss about what is solid. Suppose take an example of solid pen. Pen having definite volume, pen having definite shape. Pen ର କିଛି definite volume ଅଛି, definite shape ଅଛି. ଆଉ ଆମେ ଜାଣିଛୁ pen is a solid. That means solid is the matter which is having definite volume and definite shape. We can take another example, chair. Chair having definite volume, definite shape. We can take another example, carbon. Carbon having definite volume, definite shape. Iron. Iron is also an example of solid because these substances having definite volume and definite shape. Next I will discuss about what is liquid. Suppose take water. Water having definite volume, but remember water do not have definite shape. It depends upon the container. जो कंटेनर रे रखिबा तमे वाटर को से अनुसार तार शेप डिटरमाइन हो. Suppose you will take water in a bottle, then the shape of water is like bottle shape. If you will take water in a tin box, then the shape of water is tin box. That means water having definite volume, no doubt, but the shape of water depends upon the shape of container. That's why water is a liquid. From this example, it is clear that the matter which is having definite volume but do not having definite shape is called liquid. Similarly, I will take an example of gas, hydrogen gas. Hydrogen gas do not having definite volume. Also, hydrogen gas do not having definite shape. Hydrogen, if I will take in a 5-liter cylinder, then the volume of the gas is 5 liter. Suppose I will transfer the 5-liter gas into another cylinder which having volume 2 liter. Now the volume of the gas is 2 liter. There is only difference is the pressure. Suppose I will take this gas to another container which having volume 10 liter. Now the volume of the gas is 10 liter. From this data, it is clear that the volume of the gas changes. That means the volume of hydrogen gas is not definite. Similarly, now I will explain about the shape. Depending upon the shape of container, the shape of the gas will be decided. Whether it is cylindrical, whether it is a bottle shape, like this. From this example, it is clear that the shape of gas is also not definite. That means gases are the matter which do not have definite shape and definite volume. There are lot of examples of gas like your nitrogen gas, oxygen gas, carbon dioxide gas, like that. There are also lot of examples of liquid, water, milk, honey, kerosene, petrol, like that. This is all about the physical classification of matter. Next I will discuss about the chemical classification. Chemically, matter can be classified into two types. One is your pure substance, second is your mixture. Pure substance means vishuddha padartha. Mixture means mishran. Suppose I will take examples of pure substance. Water. Another is your iron. Suppose I will think about the matter water. The matter water is made by only one component, that is your water molecule. माने एकाधिक वाटर मॉलिक्यूल द्वारा वाटर मेटर तैयारी होइछि. Similarly, I will think about the metal iron. Iron metal is made by many iron atoms, and that is also one component. From this discussion, it is clear that both water and iron made by only one component. Now I will discuss about the composition. Both water and iron having definite composition. Both water and iron having definite properties. आयरन आम जो आनिले आयरन रे रस्टिंग हम वेदा तुम इंडिया आयरन को केबा ऑस्ट्रेलिया आयरन को आयरन मीन्स रस्टिंग. तो आयरन हैविंग डेफिनाइट प्रॉपर्टीज, बोथ फिजिकल प्रॉपर्टी एंड केमिकल प्रॉपर्टी. Generally, we concluded that both water and iron made by only one component, having definite composition, having also definite properties. Here, water and iron are called pure substance. That means, what is the meaning of pure substance? Pure substance is the matter which is made by only one component and having definite composition and definite property. Let me explain about the iron. Iron is the simplest form of matter. Iron cannot build from another simpler matter. Iron cannot break into simpler matter. Let me explain about water. Water is made by two or more elements in a definite proportion. Suppose I will think about water. Water is made by two hydrogen atom, one oxygen atom. If I want to think about the mass of hydrogen is 1. There are two hydrogen, that means 2 into 1. The atomic mass of oxygen is 16. There are one oxygen atom, so I can write 1 into 16. Then I can take the ratio of hydrogen and oxygen according to their mass. That means 2:16 equal to 1:8. Water is made by 1:8 by mass. If I will change the ratio, then it will give another compound, another matter. For the formation of water, it is bound to maintain this ratio, otherwise it will not give the water. From this discussion, it is clear that water is made by two or more elements in definite proportion. On the other hand, iron is the simplest form of matter. It do not break into simpler matter, or it cannot form from simpler matter. From this discussion, it is clear that pure substance is two types. One is your element, another is your compound. Here, iron is the element, water is the compound. What is element? Element is the simplest form of matter which cannot break into simpler matter nor build from simpler matter. Element को आमे ओडिया रे मौलिक बोली कहि थाओ. Compound means यौगिक. What is that? definition of compound. Compound is made by two or more elements in a definite ratio, that is your definite proportion. In case of compound, the ratio must be taken by mass. Next I will explain about what is mixture. Mixture is made by two or more elements or two or more compound, but they are not in a fixed ratio by mass. That means the ratio may be changes. Take an example of mixture of carbon and sand. This is an example of mixture. Finally, we concluded that chemically matter can be classified into two types. One is your pure substance, another is your mixture. Pure substance again classified into two types. One is your element, another is your compound. There are three terms. One is your element, another is your compound, and third is your mixture. These two terms related to the pure substance. Let me explain what is the element and what are the types of element. Element is the simplest form of matter which cannot build from simpler matter or cannot break into simpler matter. Element can be classified into three types. One is your metal, another is your non-metal, third is your metalloid. Let me explain what is metal, non-metal, metalloid. Suppose I will take an example of metal, iron. Iron having some special characteristics property. First point is it is able to conduct heat and electricity. This is the main point. Second point is iron has malleability character. Third is iron having luster property. Able to conduct heat and electricity means Vidut superimply. Heat conduct means tapa superimply. It has also another property like your hard, rigid, brightness like this. Iron having the following properties. Iron is the metal we know very well. That means what is the meaning of metal? The element which shows the characteristics property like able to conduct heat and electricity, having malleability, luster, having also hard, rigid, brightness, that is called metal. Like that, now I will think about non-metal. Suppose carbon. समझते जानते हो अंगार carbon. Carbon except graphite. Graphite is an exceptional gas. Carbon unable to conduct heat and electricity. Carbon do not have malleable character, also do not have luster character. Carbon is not hard and rigid like that. Carbon do not give the brightness property. You can take another example also, non-metal, hydrogen. Hydrogen is a non-metal. It is unable to conduct heat and electricity. It do not have malleability character. It do not have luster character. It is not hard, rigid. It do not have any brightness. These are called non-metal. What is the meaning of non-metal? The non-metal is an element which is unable to conduct heat and electricity, do not have malleability character, do not have luster character, do not have hardness like that. But it has another special character, that is your brittleness. भंगुरता जोटा आम कहे भंगुरता. मेटल मीन्स धातु, नॉन मेटल मीन्स अधातु, मेटालॉइड मीन्स उपधातु. Next I will explain about the metalloid. The element which shows both the characteristic property of metal, non-metal are called metalloid. Example is your strontium, germanium, arsenic, like that. These are the classification of element. Next I will discuss about the compound. Compound is the pure substance which is made by two or more elements in a definite ratio. Already discussed. That is your, you think about the water. Already I have discussion kari sarle water विषय. Compound are classified into two types. One is your organic compound. Another is your inorganic compound. Organic compound means जैव यौगिक, inorganic compound means अजैव यौगिक. Take an example of organic compound, carbohydrate. Tell me, carbohydrate is prepared any mineral, खनिज पदार्थ? No, it cannot be prepared from any mineral. Carbohydrate can found any stone? No, it cannot be prepared from any stone. Carbohydrate can be synthesized from plant or animal. These are the living organism. Living organism. Suppose take an example for inorganic compound, rock salt, खनिज लवण. It cannot be prepared from living organism like plant and animal. It is found from non-living source like your mineral, rock, etc. From this example, it is clear that the compound which is derived from living organism like plant and animal are called organic compound. On the other hand, the compound which is derived from non-living sources like mineral, rock, etc. are called inorganic compound. Example is your carbohydrate, protein. These are the examples of organic compound. The example of inorganic compound is your rock salt, marble, washing powder, etc. This is all about your compound. Next I will explain about the mixture. Remember an important point. Mixture can be prepared from element or compound, but it is not necessary to take the element or compound in a fixed ratio. Now I will explain about mixture by taking some example. Suppose I will take a mixture water plus sugar. Another example is water plus sand. These two are called mixture. Suppose I want to prepare sugar solution. 10 gram of sugar will be dissolved in 1 liter of water. Suppose I will prepare another sugar solution. 100 gram of sugar will be taken in 1 liter of water. Similarly, I will take 1000 gram of sugar in 1 liter of water. Any problem? No problem. किसी भी problem हो, we can prepare a sugar solution. But what is the difference? This is the only difference is in their taste. They are having different tastes. Here the sweetness is more. Here the sweetness is the least. All are said to be mixture. There is only difference in their sweetness due to difference in the amount of solute. Look at that, here the solvent is fixed, but there is difference in the solute. That means they are taken in different ratio. If I will change the amount, then there is no problem for the preparation of sugar solution. Similarly, I will take different amount of sand in different amount of water or particular amount of water. The formation of mixture is no problem. You can prepare the mixture, but they have been different in concentration. गाढ़ारे परिवर्तन नहीं पारे, किंतु mixture तैयारी हो. किंतु हमें water कथा जिदी करिबा, water तैयारी करिया ପାଇଁ generally we take 2 hydrogen, 1 oxygen. If I will change the amount, suppose I will take 2 hydrogen, 2 oxygen, then it cannot give the water, it gives hydrogen peroxide. आमे दीटा हाइड्रोजन गोटे ऑक्सीजन नहीं की वाटर की करि परिबा, किंतु दीटा हाइड्रोजन दीटा ऑक्सीजन नहीं की आमे केबे हेले वाटर तैयारी करि परिबानी, आमे हाइड्रोजन पेरोक्साइड तैयारी करि परिबा. आमे दीटा हाइड्रोजन गोटे ऑक्सीजन नहीं की वाटर नहीं की हमें पी परिबा, किंतु दीटा हाइड्रोजन दीटा ऑक्सीजन नहीं की हमें वाटर बोली भाबी पीबानी, हमें मर जिबा की, because we cannot prepare water molecule. From this it is clear that compound is made from element, mixture is made from element or compound. In compound there must be a key point, that is you should maintain the fixed ratio by mass, but it is not necessary to maintain the fixed ratio by mass in case of mixture. Look at that, here is an also interesting point. Suppose I want to take this mixture in a big car. This is your big car. Suppose I want to take this mixture into another big car. This is your another big car. In case of this, if I will take 5 ml from top and another 5 ml from bottom and another 5 ml from middle, then what will happen? These 5 ml having same sweetness as compared to with these 5 ml as compared to these 5 ml. I mean, जो भी आनिले sweetness समान रहेगा. That means, what is the point? That means in every portion of the 5 ml of sugar solution contain same amount of sugar molecule. From this it is clear that the sugar molecule is uniformly distributed throughout the solution. Now I will think about this mixture which is taken in this beaker. If I want to take 5 ml from the top, then I can only found water. Suppose if I want to take 5 ml from the bottom, then I can only found sand. If I want to take 5 ml from the middle, then I can found water plus sand. From this experimental data, it is clear that the sand particle do not distribute uniformly throughout the solution. In this case, the sugar particle uniformly distributed throughout the solution, but in this case, the same particles do not distribute throughout the solution uniformly. Here the composition is the same, here the composition is not same. From this data it is clear that mixture is also classified into two types. One is homogeneous mixture, another is your heterogeneous mixture. This is your homogeneous mixture, this is your heterogeneous mixture. Remember another point. Here two phases are present. One is your water phase, another is your sand phase. But here only a single phase. Phase means stara. Suppose I will take another example. Water plus oil plus sand. Tell me, this is which type of mixture? This is homogeneous or heterogeneous? Obviously it is an example of heterogeneous. There are three phases. One is your water phase, another is your oil phase, another is your sand phase. And the particles present in the mixture do not distribute uniformly. At the top, oil is present. At the middle, water is present. At the bottom, sand is present. If I will take this mixture in a beaker, then the top part oil is present, in the bottom part sand is present, in the middle part water is present. From this data it is clear that homogeneous mixture is the mixture in which the composition is the same throughout the single phase of the system. On the other hand, heterogeneous mixture is the mixture in which the composition is different throughout the two or more phases of the system. Here single phase, here two or more phases are present. Let me explain air. Air is a homogeneous or heterogeneous mixture. Air is a homogeneous mixture. Similarly, brass, bronze, these are the example of homogeneous mixture. What are the example of heterogeneous mixture? Mixture of sand and sulfur, mixture of oil and water. These are the example of heterogeneous mixture. Next, I will discuss about the particle nature of matter. Matter is made by two small particles, such as one is your atom, another is your molecule. Atom means paramanu, molecule means anu. Atom is the simplest form of element which can take part in the chemical reaction. And remember another important point, atom may have independent existence or may not have independent existence. On the other hand, molecule is the simplest form of element or compound, but it has completely independent existence. It do not take part in the chemical reaction. Molecule can be classified into two types. One is your homoatomic molecule, another is your heteroatomic molecule. Homoatomic molecule again divided into different types. That is your monoatomic molecule, diatomic molecule, triatomic molecule, like that. Similarly, heteroatomic molecule also divided into different types, diatomic, triatomic, tetratomic, like that. Take some example of homoatomic molecule. Helium, neon, argon, O2, N2, O3, P4. These are said to be homoatomic molecule. Homoatomic molecule are the molecule which is made by same type of element. Look at that. Here only one type of element is present. In this case only oxygen is present, in this case only phosphorus is present, in this case only nitrogen element is present. But these three are called monoatomic molecule and these two are called diatomic molecule. This is your called triatomic molecule, this is your called tetraatomic molecule. Suppose I want to take the example of heteroatomic molecule. HF, CO2, CO, H2S, CH4. These are the example of heteroatomic molecule. Look at that. This type of molecule is made by two or more type of element. This is your called diatomic molecule. Here the number of atom is your 2. This is your called triatomic molecule. Here the number of atom is your 3. This is your called diatomic molecule. This is your triatomic molecule. This is your pentaatomic molecule. From this discussion, it is clear that molecule is divided into two types. One is your homoatomic, second is your heteroatomic. These are the example of homoatomic molecule. These are the example of heteroatomic molecule. Homoatomic molecule again classified into different types, such as number 1 is your monoatomic, number 2 is your diatomic, number 3 is your triatomic, number 4 is your tetraatomic molecule. Similarly, heteroatomic molecules also classified into different types, such as diatomic. Next is your triatomic, next is your tetraatomic, pentaatomic, like that. Next I will discuss about the properties of matter. Matter dharma mein padhiba. There are two types of property of matter. One is your physical property, another is your chemical property. Physical property means bhautika dharma. Chemical property means rasayanika dharma. Simply think that physical property means that property in which the composition cannot be changed. Chemical property means the property in which the composition will be changed. What are the examples of physical property? Melting point, boiling point, rigidity, hardness. These are the example of physical property. What are the example of chemical property? Rusting of iron, burning of wood. These are the example of chemical property. The main difference between physical property and chemical property is only the change of composition. Physical property रे हमर composition change हबा नहीं, chemical property रे composition change हबो. This is the main difference. Next I will discuss about symbol. आमे आको प्रतीक बोली कहि था. Suppose I want to explain the symbol with example hydrogen. Suppose take an element that is your hydrogen. The symbol of hydrogen is your H. What is H? H is the shorthand representation or abbreviation of full name of hydrogen. That means symbol is the shorthand representation or abbreviation of the full name of an element. गोटे एलिमेंट रो पूरा लिखिया परिवर्ते आमे ताको सिंबल द्वारा शॉर्टली रिप्रेजेंट करिथौ. फॉर एग्जांपल द सिंबल ऑफ हाइड्रोजन इज योर H, like the symbol of nitrogen is your N, the symbol of oxygen is your O. These are the symbol of corresponding elements. Generally, symbols are written by the help of first letter of the full name of the element. It is written in capital form. The symbol of some element may be written by the first letter in capital. For example, oxygen, the first letter is your O, so the symbol is your O. In case of nitrogen, the first letter is your N, the symbol is your N. In some case, we use two letters for writing the symbol. For example, helium. The symbol is your He. Suppose take another example, chlorine, that is your Cl. In this case, these two letters is the first two letter. In this case, the first letter belongs to the first letter of the name, but remember, in this case, the second letter L not belongs to the second letter of the full name of chlorine. The L is present here in the third position. Symbol of some element may be derived from Latin name. For example, symbol of iron. The symbol of iron is not I. The symbol of iron is your Fe, because this symbol derived from the Latin name of iron, that is your ferrum. Similarly, you can take another example whose symbol derived from the Latin name. The symbol of some element also derived from the name of scientist. For example, curium. The symbol of curium is Cm. The Cm symbol is derived from the name of scientist Madame Curie. Similarly, the symbol of Einsteinium, which is derived from Albert Einstein. The symbol of some element can be derived from the name of country or laboratory. For example, polonium. The symbol of polonium is PO, which is derived from the name of country, that is Poland. Like that, you can also think about the symbol of American. The symbol of American derived from the name of America country. The symbol of some element also derived from the name of planet. For example, is uranium. The symbol of uranium is U, which is derived from the name of planet, that is Uranus. Like that, you can also think about the symbol of plutonium, which is derived from Pluto. The symbol of Neptunium, which is also derived from the name of planet, that is Neptune. This is all about your symbol. Next, I will explain about the valency. Valency means jotyata. The number of electron lost or gained or shared within an atom of other element in order to attain the stable electronic configuration of nearest noble gas. Noble gas means Birala gas. Noble gas are helium, neon, argon, krypton, xenon, radon. These are the noble gas elements. These elements having stable electronic configuration. Electronic configuration means electron saranchana. Because these elements obey octet rule. ओडिया ताको हमें अष्टक सूत्र बोली कहिथाउ. Except helium, the element which obey octet rule are considered as stable element and they have stable electronic configuration. The noble gases element obey octet rule, so these are considered as stable element because they attain the stable electronic configuration. Like noble gas element, every element have a tendency to attain the stable electronic configuration of nearest noble gas. For example, the element sodium. its atomic number is your 11. Atomic number means Paramanu Kramanka. The element sodium having atomic number 11, its electronic configuration is your 281. Sodium atom having a tendency to attain the electronic configuration of neon, because neon is the nearest noble gas of sodium. The neon having electronic configuration 2,8. Sodium have a tendency to lose this electron and attain the stable electronic configuration of neon. If sodium loses one electron, then it can attain the stable electronic configuration of neon. So the valency of sodium is your 1, because according to the definition of valency, we can think that the number of electron lost or number of electron gained or number of electron shared is called valency. Here sodium loses one electron and attain the stable electronic configuration of neon, so the valency of sodium is 1. Like that, you can think another example, that is your chlorine. The atomic number of chlorine is your 17. Argon is the nearest noble gas of chlorine, which is having atomic number 18. The electronic configuration of chlorine is your 287. The electronic configuration of argon is your 288. So chlorine have a tendency to gain an electron and attain the stable electronic configuration of argon. So the valency of chlorine is your 1, because here the number of electron gained equal to 1. Now I will take another example. Suppose I will take hydrogen molecule. Here two hydrogen atoms attain the stable electronic configuration of helium. To attain the stable electronic configuration of helium, each hydrogen atom share one electron. So the valency of hydrogen is your 1. Take another example, nitrogen molecule. Look at that. Here each nitrogen atom share 3 electrons. To attain the stable electronic configuration of neon, so the valency of nitrogen is your 3. Take another example, oxygen. Here each oxygen atom share 2 electrons. To attain the stable electronic configuration of nearest noble gas neon, so the valency of oxygen is your 2. An element have 2 or more valency. That type of valency is called variable valency. ओडिया रे ताको चल जोज्यता कहिथाओ. For example, iron. Iron having 2 valency. One is your 2, another is your 3. Copper having also 2 valency, one is your 1, another is your 2. Lead having 2 valency, one is your 2, another is your 4. These valency are called variable valency. Next I will discuss about the radicals. Suppose I will take an acid HCl. The acid made by 2 ions, one is your H plus, another is your Cl minus. Acid means amla. Similarly, suppose I will take a base. Base means carrier. It is also made by 2 ions. One is your Na plus, another is your OH minus. Similarly, we take an example of salt. Suppose I will take NaCl. NaCl is also made by 2 ions. One is your Na plus, another is your Cl minus. Suppose if we These are made by two opposite ions and these ions are called radical. These are called ionic compound. Ionic compound means the compound which is made by ionic bond. Ionic bond means ionic bandha. These ionic compounds like acid, base and salts are made by two oppositely charged ions are called radical. Depending upon the charge, we can classify the radical into two types. One is your electropositive radical, that is also called cation or also called basic radical. Similarly, the other type of radical is your electronegative radical, that is also called anion or also called acid radical. Simply remember, the radical which carry positive ion are called electropositive radical or cation or basic radical. The radical which contain negative ion are called electronegative radical or anion or acid radical. Here H plus is the electropositive radical, here Cl minus is the electronegative radical. Depending upon the magnitude of charge, radicals are also classified into different types. One is your monovalent radical, two is your divalent radical, next is your trivalent radical, next is your tetravalent radical, like that. Monovalent radical means it carry one unit of plus or minus charge. For example, Cl minus, Na plus. These are the example of monovalent radical. Look at that. Here, one unit of minus charge is present in Cl minus. Look at that. Here, one unit of plus charge is present in Na plus. Similarly, you can think about the divalent Ca2 plus. Another is your SO4 2 minus, next is your S2 minus, CO3 2 minus. All the radical carry two unit of positive or negative charge. Similarly, I can think about the example of trivalent radical Ti3 plus, P3 minus, N3 minus. All the radical carry three unit of positive or negative charge. Similarly, you can think about the example of tetravalent, that is your P2O7 4 minus, SN4 plus, PB4 plus. Like that, you can also think about the example of pentavalent, AS5 plus. It is an example of pentavalent radical. SB5 plus. It is also an example of pentavalent radical. These are the classification of radical depending upon the magnitude of charge. Depending upon the structure of radical are classified into three types. One is your simple radical, number two is your compound radical, third is your complex radical. The examples of simple radical are Na plus, Cl minus, P3 minus, N3 minus. These are the examples of simple radical. The example of complex radical are SO4 2 minus, NH4 plus, Cn minus, etc. The example of complex radical are Fe, Cn6a 3 minus, Hg Hg, NH3 twice plus etc. How can you identify which is a simple radical, which is a compound radical, which is complex radical? You can take another example of simple radical, that is O2 minus, O2 2 minus. These are also belongs to simple radical. Look at the examples of simple radical. In this case, this radical is made by two atoms. In other cases, the radicals are made by only one atom. No doubt it is made by two atoms, but the two atoms belongs to one kind of element, that is oxygen. That means the radical which is made by one or more than one atom, but the atoms belongs to same kind of element, that is called simple radical. Now you can think about the examples of compound radical. Compound radical is made by two or more atoms of different element. Look at that. In case of SO4 2 minus, this is made by 5 atoms. One is your sulfur, 4 oxygen atoms are present here, and these 5 atoms belongs to different type of element. One is your sulfur element, another is your oxygen element. And these two type of element combine with each other to form an entity and behaves as a radical. That means compound radical are the radical which made by two or more atoms of different element as a single entity. तार गोटे टाइप रो देखा जिवो से माने एठारे SO4 2 माइनस जो अछि S अलगा O अलगा नहीं, SO4 गोटे रेडिकल और तार चार्ज हला 2 माइनस. Now I want to explain about the complex radical. Look at these examples. No doubt these are made by two or more atoms of different element, but their structure are slightly complicated. These radicals are enclosed in a square bracket. That means complex radical are the radical which are made by two or more atoms of different element with a little complicated structure and enclosed in a square bracket. Simply remember, compound and complex radical are made by two or more atoms of different element, no doubt, but they are different in their square bracket. In case of complex radical, square bracket is present, but in case of compound radical, there is no square bracket. This is the only difference between compound and complex radical. If I want to think about the simple radical and compound radical, the simple radical made by one or more atom of same kind of element, but on the other hand, compound radical is made by two or more atom of different element. Similarly, you can think about the difference between simple radical and complex radical. Simple radical is made by one or more atom of same kind of element, but on the other hand, complex radical is made by two or more atom of different element. Here also square bracket is present. The structure of this radical is slightly complicated. These are the difference between simple radical and complex radical. This is all about the radical and its classification. Next I will discuss about the formula. Formula means sanketa. Formula is made by symbol. It is generally deals with a molecule. So I can write the symbolic representation of the molecules of a substance in terms of symbol of constituent atom is called formula. For example, formula of water is H2O. Look at that. This formula is related to the water molecule. It is made by the symbol of the constituent atom, that is your hydrogen and oxygen. Like that you can think about the formula of sodium chloride, that is your NaCl. Similarly you can think about the formula of aluminium sulfate, Al2SO4 thrice. This is all about your formula. Next I will explain about the chemical equation, रासायनिक समीकरण. A brief representation of a chemical change in terms of symbol and the formulae of the species involved in it is called chemical equation. Let me explain with example. Hydrogen react with the oxygen to form water. This is a chemical change. Here the species involved are hydrogen, another species is your oxygen, and third number species is your water. This chemical change can be briefly represented by chemical equation like that. H2 react with the O2 gives H2O. This is your chemical equation. This arrow mark indicates that this is your reactant and this is your product. In a chemical reaction, there are two parts. One is your reactant side, another is your product side. This is all about for this class. Next class I will discuss about the atomic mass, molecular mass and equivalent mass. Thank you. Have a nice day.